Welcome to 7-7 Part 2. We're going to be talking about exponential growth and decay. So here, this is what exponential growth looks like. We talked about the graphs of exponential functions in a previous video, but this is specifically the direction that the graph is going to be pointing if it's growth. So that means that B, my multiplier, is going to be greater than 1. And A is going to be positive. So the initial amount is always going to be positive, and the multiplier is going to be greater than 1 when we have exponential growth. Specifically, in an exponential growth word problem situation, B is going to equal 1 plus whatever the rate that we're given is. So if we're given a percentage, like something is increasing by 5%, then we're going to change that to a decimal, so 0.05, and then we're going to add 1, so 1 plus 0.05, so that'd be 1.05. So whatever rate we're given, if we're already given a decimal, that's fine. If you're given a fraction, make that into a decimal, and then you're going to do 1 plus that number. So if you get a fraction or a percentage, turn that into a decimal, and then 1 plus that number. If it says increasing by a factor of something, then that addition has already been done for you. So if it says increasing by a factor of 1.5, then B is just 1.5. All right. So let's look at exponential decay. So exponential decay is where we're decreasing exponentially. So exponential growth, we're increasing exponentially. Exponential decay, we're decreasing exponentially. So if we're decreasing, that's going to be, again, the initial amount is always going to be positive for exponential growth and decay. So the initial amount is positive. B, our multiplier, is going to be between 0 and 1. So it's going to be positive, but it's going to be less than 1. So in a word problem situation, to find B, that's going to be 1 minus that rate. So if I have 5%, then it's going to be 1 minus 0.05. Or 0.95 is what that would end up being. 0.95 would be my multiplier. So notice that that's below 1, right? So whenever we're dealing with decay, B should be less than 1, but it should still be positive. And we can tell in a word problem whether something's going to be growth or decay by the way the word problem describes a situation. So if it describes an increasing situation, if something's increasing by 5%, or you're getting 5% more, something like that, that's increasing, that's going to be a growth situation. If something is decreasing, so say it says that I have 5% less each time, or I'm decreasing by 5%, anything that tells you that the amount that you have is decreasing, it's becoming less, that is going to be a decay situation. So you're going to have to use 1 minus. So in word problems, you have to ask yourself, is this increasing or is this decreasing? And that will tell you whether to use 1 plus or 1 minus. So that's going to be important in word problems for exponential growth and decay. Okay, so let's look at these. So we're going to look what would be growth and then what would be decay. So again, it's calling it a factor. So we're not adding or subtracting 1. This is just the number that we already have. So growth factor would just be B, not R. It would just, they've already figured out what B is. So 85% is 0.85, right? 85% is 0.85. That's not more than 1, so that's not growth, right? That would be, yeah, that's not growth. 3 is greater than 1, so this would be growth, right? Because it doesn't say 3%, it just says 3, so that would be growth. 1/2 is less than 1, so that's not going to be growth. 1.05 is greater than 1, so that's going to be growth. 0.93 is less than 1, so that's not growth. So then decay, again, 85% is 0.85. That is less than 1, so that's going to be decay. 3 is greater than 1, so that's not decay. 1/2 is less than 1, so that's decay. 1.05 is greater than 1, so that's not decay. 0.93 is less than 1, so that is decay. So notice that if something is not growth, then it's decay, right? If it's either one or the other. The only thing that that's not true of is 1, right? If my growth factor is 1, that just does nothing. It's neither growth nor decay. It would actually end up just being a straight line. It would be, so if B were 1, which is not allowed to be, but if B were 1, then that would just be this straight line right here. And that's not useful. So we never use that because it's just a straight line. Nothing is happening. So we don't use B equals 1. We never use that. So with any other number, though, if it's not growth, it's decay. And remember, B is also never negative. It's always going to be positive. So it's positive, and if it's greater than 1, it's growth. If it's less than 1, it's decay. All right. So in the next video, we're going to look at some more examples.